Back again, we had some questions about tautologies, contingencies, etc. And the thing to remember here, this is really important, I think it confused a few people. These are in boldface for a reason. P and Q are two contingencies. That means they stand for well-formed formulas, each well-formed formula coming out true in at least one row and at least false in one row. But P isn't the well-formed formula. The well-formed formula could be anything. Likewise, Q isn't the well-formed formula. These are like variables. This is some well-formed formula. This is some well-formed formula. With that in mind, we ask, could you get a tautology when you join these two things with or? Not, is it a tautology? We obviously don't know that, but could it be a tautology depending on what contingency P is and what contingency Q is? The answer is yes. One way to see it, a really easy way to explain it, is just to take an example. Suppose that the well-formed formula that P stands for is X. Well, X is a well-formed formula that's a contingency because it's true in the first row and false in the second. If Q stands for the well-formed formula not X, likewise it's a contingency, but its truth values are the opposite of the ones for X. So putting these two together with OR would give us a tautology. It would be true in each row of the table. So the answer is yes. Depending on what P and Q are, putting them together with an OR could indeed give you a tautology, even though P and Q are both contingencies. So this is a little bit more abstract than just thinking about simple sentence letters, and that's the thing that you want to make sure you understand. Carrying on to the next question, same thing, P is some well-formed formula, Q is some well-formed formula, but as the instructions specified, P and Q are both contingencies. Could you get a contradiction when you put them together with OR? Well, the answer here is no. Whatever P is, because it's a contingency, it will be true in at least one row. So take any such row where P is true. In that row, P or Q will be true regardless of what Q is, because we'll have an OR statement with the true part. So it can't be a contradiction because it's true in at least one row. And we could have gotten to the same conclusion by reasoning about Q, because likewise, it's true in at least one row. So as I said, what's being done here is a bit more abstract. You've got to think about it at an appropriately abstract level. Don't get stuck on the level of sentence letters, or else you won't zero in on what matters. The final problem was a proof. And as proofs go, this one isn't too bad, but it did have a number of steps to it. So let's sort of think our way through it. When you're doing a proof, it's always a good idea to look at first for places where you can use information extracting rules. If you can see how to get to the proof, if you can reason backwards, that's good. But otherwise, don't spend a lot of time trying to pre-strategize. Just start using some information extracting rules. And the easiest place to do that is with line 2. We can extract the S and the P by simplification. Now we look for more opportunities to use information extracting rules. Well, there's more than one way we could go here. What I'm going to do is I'm going to look at number 5 and notice X is something it would be useful to have. It's part of what we need. We can't get to X in one step, but we can get to it in 2. If we double negate S, then we have what we need to apply disjunctive syllogism. We have an OR statement on one line. We have one of its disjuncts plus an extra tilde on another line. We can conclude the remaining disjunct. Now, still looking for information extracting rules. Here's this P. We didn't use it before, but we can apply it to 1 with the modus ponens step, and we get Q or R. So I'm just going to move things up a bit here. We've just been going along using information extracting rules. We've gotten to Q or R. What we need to finish the proof is W. Here's where the more complicated information extracting rule dilemma comes in. 3 tells us that from Q we get T and W. 4 tells us that from R we get T and W. 10 tells us that we have either Q or R. Putting those together and using dilemma, we get T and W. 3, 4, 10, dilemma gets us T and W. Here's our X. We need X and W. We can easily get W, and then we can combine them in the completed proof in 2 steps here. First we get the W, and then finally we get the conclusion that we needed. We take the X from 9, the W from 12, and we can join the two. So those are the questions on the test, and as I said, I was pleased on the whole. Most people did just fine. When you look at your score, if things were set up as they were meant to be, you'll be able to see how your score compared with the averages. But what I'd say here is that if your score was significantly off the average, or even more generally in this case, since people did so well on the whole, if your score was in the C or the low B range, I'd really like you to come talk to me so that we can figure out where the problems are and get on top of them early. On the one hand, in this course, if by the time people get to the end of the course and to the final, they show me that they've mastered the material, I will take that into account. So don't get discouraged if things didn't turn out on the first test as well as you wanted. But I will tell you this from experience, that if you let these things slip, it's just going to pile up because the material does get progressively more demanding. You have to have control of what came earlier in order to proceed with what comes later. So look this over again if you need to. Look at your test score, and please do set up a time to talk with me if you think that that would be useful.